Okay, so I'm going to start today the new topic of chemical engineering, and that is process dynamics and control. So, as usual, when I start the topic, so most of the time I used to say that what is the importance of this topic for the gate examination. And again, this topic is very, very important because when we talk about process dynamics and control, like CRE and all other topic, this topic contains 12 marks at least. If you see 10 to 12 marks in gate. And I'm telling you one thing, scoring 8 marks is very, very easy in this particular paper, right? Scoring this mark, I mean, uh, what do you say? I mean, if 5 to 6 questions are coming from plant and economics, so definitely you will be able to solve 4 to 5 questions, right? So the thing is that again, I usually what I say you in all the topics. Just wait 1 second. I'll have to share the link to one more student. Yeah. So now the thing is that I told you scoring 10 marks is very easy in this particular paper, right? And how you can score 10 marks, the thing that I'll be teaching you, and you have to practice a bit, right? So sometimes what happens, the strategy for this particular topic is try to understand the basics that is happening, because when we talk about process dynamics and control, the title process dynamics and control. So this topic consists of three particular word, that is a process, a dynamics and control. Means in this particular topic, definitely, I mean, whatever the thing we study in chemical engineering, that is unit operation and unit process. So here, generally, what we used to do is we generally model the process, right? Because when we talk about any industry, right, just try to understand we are going to, produce ammonia NH3, right? So ammonia will be formed by reaction of nitrogen plus hydrogen, right? So this reaction will be reversible reaction, right? So again, this reaction may come into the equilibrium. What is the temperature? What is the pressure that will be required to, carry this reaction always forward direction, in the forward direction and all kind of thing, right? So that becomes very important. So measuring this particular temperature, measuring this particular pressure is a kind of tedious process, right? So every time you have to maintain this particular condition, because this reaction will occur at a specific conditions, that is a specific condition of temperature, pressure. Some catalyst will be there, that is ferrous iron catalyst will be there, right? And some kind, I mean, that depends upon the situation, right? So I mean, that becomes very, very important to maintain this particular temperature and pressure, because this is a continuous process, right? So for continuous process, right, you cannot stop the process in between. So because when we stop the process in between, it requires you will lose huge amount of capital costs, right? So it's avoidable to stop the process in between. So to overcome all these situations, so that we don't have to stop the process in between, we need to apply some kind of control strategy, right? So by these particular conditions, by using this particular process, control process, what happens over here, we can maintain this particular temperature and pressure, and we can produce NH3 ammonia continuously throughout the reactor, right? So that's what the process is. Now the thing is that what is dynamics, because dynamics always, dynamics is a word which always connect with the time. Means whether the reaction, if the reaction is happening, so we can analyze in which way, I mean, you can calculate the velocity of the reaction, right? You can also calculate the time of completion of reaction, the time of attainment of the equilibrium, all these kind of things. So we will be modeling all these particular thing, in this particular subject, that is called as the process dynamics and control. So I mean, giving you one of the basic example of, let's say, a liquid stream at a temperature Ti is available, right? So let's say here there is liquid stream is coming here, right? and here this one is living. All these things already I have taught you in chemical reaction engineering, but here let's try to understand how we can model it. So this is mass in and this is mass out, right? Now we want to understand here how the mass out is depends upon time. I mean, how can we relate this m in and mass out with respect to time, right? So if we understand that if I will apply material balance, that is mass in minus mass out, that is equals to d by dt of, that is mass flow rate in, mass flow rate out, here mass flow rate in, mass flow rate out, and that is mass accumulated inside this particular thing, right? So now you can see here, this tells you the dynamics of the system. Why the dynamics of the system? The reason behind that is it will tell you at any particular time the variations of mass inside this particular area, I mean, a reactor or whatever the vessel is, right? So we can understand at a particular time. That means always we are interested in unsteady state condition, right? And till now, whatever the thing we have studied, previously, either in CRE or mostly in thermodynamics, we were studying about the thing which is in a steady state kind of thing, right? So again, the thing is that now let's try to understand one more thing. This one is a system. Already I have discussed all these things, right? Let's say this fluid is coming inside, this fluid is going outside, out, right? And what is happening over here? A coil is there, right? Let's say mass in, mass out, right? Mass flow rate in, mass flow rate out. U, area of the coil is A, temperature here is T, right? So the thing is that we are very much interested in knowing about the dynamics of this particular system. And what is the dynamics of this particular system? Because here, let's say a specific, I mean, heat capacity of system is inlet is Cp and this one is also Cp. Mass flow rate is there, inlet temperature is T naught, let's say, and here exit temperature is also T, right? So here you can see energy is coming by this particular mass flow, energy is going out this particular by mass flow, and there is also coil here that will be also supplying the energy, right? Supplying the energy. So we are very much interested in knowing about the dynamics of this particular energy of this particular system, right? How much time it will require to completely heat this particular mass of the fluid, or whatever the problem will be there. That depends upon the physics of the problem. We can understand with respect to the time of any particular parameters what we want to calculate. Let's say if mass flow rate here, either here temperature is T, after what time the reactor temperature will becomes equals to T2, let's say. So if I want to know that after how much time that temperature T2 will becomes 100 degrees centigrade if T naught is equals to, let's say, 400 degrees centigrade, right? And here cooling water is supplied over here. Now we want to know that what will be the time required. So this time will come from only the dynamics of the system, and this dynamics can be explained by this particular process dynamics and control topic, right? And it becomes very important, right, when we talk about this dynamics, right? So we'll discuss all these things later, how these dynamics will work and how we can understand the thing. So that here I'll be dividing this but process control topic in three parts, right? Three parts where I will be talking about the dynamics of the process, dynamics of various processes. Then I will be talking about controller, and then I'll be talking about advanced control strategy. And here in this controller, I will be talking about frequency response also. So let me tell you one more very important thing. From here, you used to get generally 4 marks, right? And it's very, very important. Already told you, I have told you topic is very important. From controller, you will get 2 marks. From frequency response, sure and certain, you will get 2 marks, right? From advanced control strategy, let's try to understand 4 marks will be there. 3 to 4 marks will be there, right? 3 to 4 marks will be there. So this is the Marks distribution in process dynamics and control topic, right? So this topic is not very tough, but if you understand the thing, this is right, the physics of the problem. If you understand the physics of the problem, then definitely it will becomes very easy for you to understand the thing, right? So I'll suggest you to try to understand the basic thing over here in this particular topic, so that the topic will be very easy for you. Some mathematics will require for this particular topic that I'll teach you today, right? Which kind of mathematics is required, right? I and I hope the essence of this topic is clear to all of you. Why we use control strategy? Because you know that when we talk about this particular topic, the name is control, right? So definitely, let's try to understand. I'm telling you the basic thing over here. If this is a overhead tank in your home, right? Everyone would have seen this particular thing, overhead tank in the home, and some water, some pump is there that will be lifting the water from the ground level, right? This is the ground level. And what happens after a certain time, this tank will get filled with completely of water, right? So you have to turn off this particular supply line somewhere else, right? So you will turn off this pump, and after that the flow of water will get restricted, right? So the thing is that how you can understand how much time it will take to fill the whole, supply tank by this particular pipe, this particular inlet pipe, right? That is very important. So again, you are very much interested in calculating height of tank. Let's say this one is height, and height with respect to water as well, because I mean the height of the tank will signify the height of the water inside the tank, and height with respect to time. So we are very much interested in knowing this particular thing. So again, height is a function of time. So this is the dynamics of this particular tank. So in this particular topic, we will be studying about the time required to completely fill the tank, completely fill the tank. Right, one kind of problem is there, this kind of problem can come, or sometimes you will understand that some reaction is going on here. In this particular reaction, here our reactant is flowing continuously, here our product is there, right? So this one is a exothermic reaction or endothermic reaction, that depends upon the situation, I'll tell you later. And already I've discussed these things in the CRE also. So here, your Ca naught will be there, here Ca will be there. Your reactant is at T naught, here this will be T, here this will be T, right? So you are here, your coolant is flowing continuously, right? This one is coolant over here, right? And here reactor is continuously flowing over here with the temperature T naught. Let's say a reaction A is getting converted into B. So what happens? Let's say this one is exothermic reaction. So once the reaction is exothermic reaction, what will happen during the process of the reaction? What happens? The huge amount of heat will get generated inside the reactor, right? So you have to remove this heat to make this reaction into the forward direction, right? Otherwise, the conversion will get decreased, right? So what happens? You have to increase the flow rate of this particular coolant, right? This one is a coolant. So you'll have to open this valve so that the coolant flow rate will increase over here, and it will be continuously taking the heat from the reactor to the outside, right? And here it is a coolant outlet, let's say. So what happens over here at a T naught temperature, you are supplying here it is a FA naught flow rate of the reactant, right? So what happens? We can analyze after, I mean, how much time it will require, you know uh, at a particular time, how much flow rate is required over here. So we can, even if we can calculate the concentration over here as a function of time, concentration over here, temperature of this particular reaction mixture with respect to time, temperature can be calculated with the function of time and all. So again, this one is telling you the dynamics of the system. What is dynamics? At a particular time, at any particular time, you can know about what is happening inside the reactor, right? So that's what the process dynamics and control tells us, right? So I hope all these things are basic essence of this particular topic that I am going to teach you today. right? So before moving to all these control strategy and all, first of all, we have to understand about some mathematics, because this topic is thoroughly, depend on the mathematics. So I'll be discussing first mathematics, and in mathematics, I'll be discussing about the Laplace transform, right? So what Laplace transform is, it helps us, it help in solving the differential equation with boundary values without finding the general solution and the value of arbitrary constant, right? So it's very important concept in the mathematics that provides us a flexibility. Let's say your equation is d2y upon dx square plus 5x plus 6 y, that is equals to 0, let's say, right? 5 dy by dx. Now if you want to solve this particular equation, so what happens, you will get a general solution, that is y of x here, that is equals to c1 exponential something plus c2 exponential something, let's say. So this is your general solution. And once you got the general solution, since this is a second order differential equation, so you will require two boundary condition to solve this value of constant c1 and c2, right? So again you will substitute boundary condition first, and again you will substitute boundary condition second, and after substitution you will get two linear equation, linear or non-linear equation, whatever way. And once you will solve these two equations, then you will be getting the value of c1 and c2, right? But in Laplace transform, it provides a flexibility without finding the general solution and without finding the arbitrary constant. I'll let you know right now how you can solve the differential equation with the help of the Laplace transformation, right? So in process dynamics and control, because we will be dealing with, most of the time we will be dealing with differential equation, let's say dh by dt plus 5h is equals to 0, d2h by dt2 plus 3 dh by dt plus 6h is equals to 0. So we will be dealing with these kind of equations, right? So every time if we calculate, if we solve this particular differential equation, let's say second differential equation, what happens over here, you will be getting a solution of y with respect to function of temperature c1 plus something c2, function of here t and here function of t, let's say f1 and f2. So now, after getting again what I have explained you, you have to calculate the value of C1 and C2, right? So again, this becomes a bit more calculative process that you want to avoid. And if you want to avoid the calculation of all these general equation and all these C1 and C2, so you have to do this particular solution with the help of Laplace transform. And Laplace transform will tell you directly about the dynamics of the system. That's very important over here, right? So without wasting our time, let's jump to the Laplace transform, how we do the Laplace transform. So the Laplace transform is, so I will be assuming let ft be a function defined for all positive value of t, right? Then your capital Fs, that is equals to 0 to infinity e to the power minus st into ft dt. This Fs is called as the Laplace transform. So you will be given ft and you have to calculate Laplace of ft. So you have to apply this formula, right? This formula is very important. So, and provided that here ft is defined in the domain 0 to infinity, right? So ft must be defined in this particular domain, right? If ft is not defined, then you cannot apply this formula for the Laplace transformation. So our fs is, I'll tell you later how this formula becomes very important when we do the calculation over here. So this is the basics formula of fs. Let's say if any function let I'll be discussing important formula, then you will get to know. First, the Laplace of 1, that is equals to 1 divided by s, right? So how we can prove Laplace of 1 is 1 divided by s? So what is our function? Function ft is our 1. So I want to calculate capital Fs, that is our Laplace. So that is equals to 0 to infinity e to the power minus st multiplied. Our function ft is your 1. I will be writing dt. So this is equals to integral e to the power minus st 0 to infinity and dt. So the integration of exponential function is e to the power minus st divided by minus s. And now I'll be substituting the limit of the integration over here because this is a definite integral, right? So once I'll substitute here, so I'll be taking common 1 upon s minus 1 upon s e to the power minus infinity minus e to the power 0, right? So this will becomes equals to what? 0, right? And this will becomes equals to 1. So finally you will be getting 1 by s. So your Laplace of 1, that is equals to 1 by s. So we have proved these things. This is a basic integration that anyone can do, right? But I'll tell again, I'll suggest you there are lots of formula in this particular topic, but once your basic is clear, if you are able to work on this particular formula, then definitely the thing will be very easy for you, right? So try to stick in the basic thing, right? Now, when we talk about second formula, Laplace of e to the power at, right? So how we can prove these things? What will be the value of Laplace? So I told you Fs is equals to what? 0 to infinity e to the power what? Minus st into ft dt. This is the Laplace. So here our function ft is equals to what? E to the power at. Fine. So then I'll substitute here your Fs, that is equals to 0 to infinity e to the power minus st into e to the power here at, and this will be equals to dt. So I'll be taking 0 to infinity e to the power minus s minus a and t dt. Again, this is exponential function. So the integral of exponential function is e to the power minus sa t divided by s minus a, and once I'll substitute the integral limit 0 to infinity. So again I'll take common 1 upon s minus a, and here you can use e to the power minus s minus at minus e to the power into, I'll substitute multiplied with infinity and e to the power, that one will be 0. Fine. And here there will be a minus sign. So finally this will becomes equals to, this will become 0. So minus 1 upon s minus a multiplied with minus 1. So that is equals to 1 upon s minus a. So finally we have got the Laplace of e to the power 80 that is equals to 1 upon s minus a. I hope these things is clear to all of you, right? So similarly, again, we can do the Laplace transform of some another function, that is our third function, that is Laplace of cos 80, and this is equals to s upon s square plus a square. This is s. And the fourth Laplace of sin 80, that is equals to a upon s square plus a square. Next function is Laplace of cos of hyperbolic 80, that is equals to s upon s square minus a square, and again Laplace of sine of hyperbolic 80, that is equals to a upon s square minus a square, right? Now next 7, and it's very important formula, Laplace of t to the power n, that is equals to factorial n divided by s to the power n plus 1. So all these formulas are very very important, and that will be used in this particular topic. So let's try to understand. I am not going to prove this formula. This is homework for all of you. This is very simple thing. I'll be proving that second number, Laplace of t to the power n. So your ft is your t to the power n. So we when we so your fs is equals to integral 0 to infinity e to the power minus st, and I have told you that is ft dt, fine. So once I'll substitute the value of ft, e to the power minus st is over here, and ft is your t to the power n and dt. So now what you see over here, this is a islet. You can use the islet, and after that you can calculate the value of this particular integrals. All right. So one way is to use the islet, right? And second way is you can use, since this is integration only, right? So I'll be using let st is equals to x. So your t is equals to x divided by s. So I can use t is equals to 1 upon s dx, right? So I'll be substituting these things over here. So I'll be getting 0 to infinity and e to the power minus x, and t is your x to the power n divided by s to the power n, fine, multiplied with 1 upon s dx, fine, as simple as that, right? So that will be equals to 1 upon s to the power n plus 1, I'll take common, and it will be equals to 0 to infinity e to the power minus x and x to the power n dx. And if you remember that you must have studied this particular one formula in your bachelor's, that integral 0 to infinity e to the power minus x into x to the power n dx, that is equals to gamma function, and this is defined as the gamma n plus 1. And one more formula, your gamma n plus 1 is used to be the value of factorial n. So this formula you must have studied. That's a very, very important formula if you remember. So finally, what can I substitute over here? This I can substitute as a function of gamma function, right? So integral your fs, that is equals to 1 upon s to the power n plus 1 and multiplied with that gamma n plus 1. And gamma n plus 1 I can write that is factorial n divided by s to the power n plus 1. So now we have proved that Laplace transform of t to the power n, that is equals to factorial n divided by s to the power n plus 1, where n is equals to what? 1, 2, 3, so and so forth, right? So this is very important formula, and it can be used, I mean, it will be used very frequently in this particular topic, process dynamics and control, right? So I have proved this particular formula also. So again, I am just using this basic formula of, I mean, Laplace transform. This is the, you know, basic formula that you should keep in your mind always whenever you are dealing with process dynamics and control. I hope these things is clear to all of you. Fine. Now, once we understand these things, there are some another top, I mean, mathematics which is related with process dynamics and control. And that mathematics is some properties of Laplace transformation. Laplace transform of 0. I have told you, no, Laplace transform of 1 already. Here I have proven, no, Laplace transform of 1 is 1 by s. Already I have proven here, right? Now, when we talk about Laplace transform of 0, right? So, Laplace transform of 0. Let's try to understand. I have not seen these things here. So, I can write 0 to infinity e to the power minus st multiplied with 0 dt. So, this will be equals to 0. That's it, right? So this is Laplace transform of 0. And 0 is 0 function, so there is no meaning of calculation. Now I'll be moving forward towards the properties of Laplace transform. So I told you that first property, that Laplace transform of a f1t plus b f2t. So these are the two functions, right? If there are two functions, then you can individually, again the rule of mathematics is applicable, associative law is applicable. So that A multiplied with Laplace transform of f1t plus B multiplied with Laplace transform of f2t. Similar. You don't have to, we don't have to prove this particular thing, just you remember. Let's say question is, if someone is asking Laplace transformation of cos t plus 3 sin t. So just you have to understand 2 into Laplace transform of t plus 3 into Laplace transform of sin t. So Laplace transform of t is equals to 2 divided by s square plus Laplace transform of 3 sin t is 3 into sin is 1 upon s square plus 1. So the Laplace transform will be equals to 2 upon s square plus 3 divided by s square plus 1, right? So you will be getting this particular function, Laplace transformation, right? I hope these things is clear to all of you. This is some basic property of Laplace transform that you need to understand, right? Now, moving towards some next property of Laplace transform, and it's a very, very important property that will reduce your calculation time and calculation mistake. That is first shifting theorem. What first shifting theorem says is, let Laplace transform of ft is equals to fs. Let if Laplace transform of ft is equals to fs, right? Then Laplace transform of e to the power at into ft, right? That is equals to f s minus a directly. I think this would be very confusing to all of you right now, but let's try to understand how I can do these things. So your ft is over here is e to the power at into let's say mm, t, right? Your ft is t into e to the power at, right? It's very easy thing. So I want to calculate the value of directly. I'll be solving first for this one. After that, we'll. So now, how these things is coming, let's try to understand how this formula is coming, right? So if I want to calculate over here, so I can write this one is 0 to infinity e to the power minus st into e to the power at ft dt. So directly I can write 0 to infinity e to the power minus s minus at into ft dt, right? Now, let I'll assume R is equals to S minus A, right? R is equals to your S minus A. So can I write here that is 0 to infinity e to the power minus RT into Ft dt, e to the power minus RT into Ft dt, right? So again, this is directly what? This one is a Fr. Are you getting it? This one is your Fr, and R is equals to S minus A, so I can substitute that is F S minus A, right? So this is how we prove this first shifting theorem. So, but if it's a very simple proof that is the only mathematics is involved over here. That's elementary kind of mathematics. But when we talk about, let's try to solve one problem over here, right? Laplace transform of, let's say, e to the power at into 1, right? So I just told you Laplace transform of a 1 is equals to 1 upon s, right? Now, here if it is 80, I told you Laplace transformation of e to the power 80 into 1, it should be 1 upon s minus a, right? 1 upon s minus a. How we can prove it? So I can write Laplace transform of this one is integral 0 to infinity e to the power 80 into e to the power minus st dt. So that is equal to integral 0 to infinity e to the power minus s minus a t dt. That is equals to minus 1 upon s minus a and e to the power minus s minus a 0 to infinity. Once you will substitute the limit, you will be getting minus 1 upon s minus a and e to the power minus infinity minus e to the power 0. So this will becomes equals to 0. So finally you will be getting 1 upon s minus a, right? So if you see directly, if there is e to the power 80 something and here there is a function, directly you substitute s minus a kind of thing, right? Again, if I want to do calculation of Laplace of, let's say, e to the power 80 into anything, uh, let's say t. So now, how can you solve these things? By first shifting theorem, just you try to understand Laplace of t, that is equals to 1 upon s square. Now, here this is 80, so just substitute here s is equals to s minus a. So, your Laplace of e to the power 80 into t will become equals to 1 upon s minus a whole square. Let's say, fine. Now, let's say if I want to calculate that Laplace of e to the power 80 into sin t. So since you see here, there is a Laplace of e to the power 80 included over here. So first I'll calculate Laplace of sin t. Laplace of sin t is 1 upon s square plus 1 because a over here is 1. Now substitute s is equals to s minus a over here. So I can calculate Laplace of e to the power 80 into sin t, sorry, that is equals to 1 upon s minus a whole square plus 1. Let's see if I want to calculate Laplace of e to the power 80 into cos t. So now you can directly write s upon s minus a divided by s minus a whole square plus 1, right? So let's say if I want to calculate Laplace of e to the power 80 into t to the power n, right? What will be the value? So how can I calculate? So since first I'll calculate ft are t to the power n, so Laplace of our ft, that is equals to factorial n upon s plus a, I mean s to the power, already I have told you this formula, s to the power n plus 1. Now here you substitute s is equals to s minus a. So finally you will be getting the formula of Laplace of e to the power 80 into t to the power n, that is equals to factorial n divided by s minus a whole to the power n plus 1. So this first shifting theorem will reduce you. I mean, again, if you will be calculating this particular formula, I mean, Laplace in transform of these things by simple math formula that I have told you right there earlier. So it will becomes very tough and huge. It will require huge calculation step. But by this first shifting theorem, you can directly see that in a single, step, you will be able to get the answer, right? This is what the first shifting theorem provides you the flexibility of calculating this kind of Laplace transform. I hope this thing is clear to all of you, right? Anyone has any doubt? Okay, so if you don't have any doubt, then will move forward towards the some next concept, the next formula that is very important. The first formula is Laplace of e to the power at into t to the power n. We have just derived this thing, that is factorial n upon s minus a whole to the power n plus 1. Next formula is Laplace of e to the power at into sine bt. So we have just derived this formula, that is b divided by s minus a whole square plus b square. So Laplace of e to the power at into cos bt, that is equals to s minus a divided by s minus a whole square plus b square. That similar formula is there that I have discussed with you earlier, that Laplace of e to the power at into sine hyperbolic bt. So this is equals to v divided by s minus a whole square minus b square. The fifth formula is Laplace of e to the power at into cos hyperbolic bt. So that will be equals to s minus a divided by s minus a whole square minus b square, right? So these are the formula that is very important and you should understand these things, right? So one very important question is how to calculate Laplace of t to the power minus 1 by 2. So I told you one formula, that is gamma n plus 1, right? Right? That is equals to n gamma n, or that is equals to factorial n, right? So here in this particular formula, if I will substitute n is equals to minus 1 by 2, right? So can I get Laplace of t to the power minus 1 upon 2, that is equals to factorial n, and factorial n can be written as n plus 1 gamma. So minus 1 by 2 plus 1 divided by s to the power minus 1 by 2 plus 1. So that is equals to gamma 1 by 2 divided by s to the power 1 by 2. And the value of gamma 1 by 2, you must have studied these things, that is equals to root pi, that you need to remember. So that will be equals to root pi divided by s to the power 1 by 2. So your value of Laplace transform of t to the power minus 1 by 2, that is equals to root pi divided by s. Right? This thing is also very important that you need to understand and you should keep in your mind. Sometimes gate will give you some kind of questions where you will incurred with kind of this kind of Laplace of minus t to the power minus half kind of thing. So you have to keep in your mind that gamma of 1 by 2, that is equals to root pi. This you must have studied in the mathematics side. Now this was the basic Laplace transform of uh, that is being used in this particular topic. Now, there are some very important concept. That is the main concept that we will be using here in this plant design, process and control. That is Laplace transform of derivative. And with the help of this one, we can calculate solve any particular differential equation. That is what I was talking about in the talking in in the starting of this class. So let's say first Laplace transformation of f dash t, right? And what is f dash t? F dash t is dft divided by dt. That is differential, first differential, right? So Laplace transform of f dash t is equals to s of Laplace of ft minus f0, right? Now, I have told you there are some property that is involved in the differential, I mean, Laplace transformation. Since this one is one function, this one is second function, so I can use s into Laplace of ft minus s into, and this will be here only. These things you need to remember in your mind because we don't have to prove these things over here. F0, right? So your Laplace of f dash t, if you want to calculate, so it will be equals to s into Laplace of ft, right? Minus f0. And we know Laplace of ft is equals to fs. So your Laplace of f dash t, that is equals to s multiplied with fs minus f0. Fine. This one is the first formula. The second formula is, let's say nth order differential is there. Laplace of at fn t. And what is fnt? Fnt is equals to dn ft divided by dt and nth order differential. This is called as nth order differential. Right? So the value of nth order differential is s to the power n Laplace of ft minus s to the power n minus 1 f0 minus s to the power n minus 2 f dash 0 minus, right? So and so forth, f to the power n minus 1 0. Alright, this is very important formula that you need to keep in your mind whenever you are solving the problem. So these two formula is used to calculate the differential equation in the with the help of the Laplace transform, right? So I'm just giving you the smallest differential equation today. After that we'll move forward. Let's say this one is dy by ds plus 4y, that is equals to 0. Now we want to solve these differential equations. How we can solve? I told you, sorry, dy by dt. So what is the value of dy by dt over here? So I can write s into y s. Here this is ft and Laplace transformation of ft is equals to what? Fs. So I'll be writing here, let's say ys minus y0 plus 4 ys, that is equals to 0. So I'll take common s. So s plus 4 minus y0, that is equals to 0. So you the value of ys you can directly calculate, that is y0 divided by s plus 4, right? I'm just assuming ys is your function. Your ft is your, let's say, y, right? And Laplace of ft, that is equals to fs, and that is equals to, I'm assuming this one is ys, right? This is the way that someone can calculate the value of differential equations with the help of the Laplace transformation, right? And again, in the subsequent class, I'll tell you how, I mean, this method will provide you huge flexibility while solving some kind of, complicated differential equation kind of question, right? So I hope these things is clear to all of you. Again, I'll be talking about differential and integral tomorrow also because I don't have that much time to discuss about differential and integral part of this Laplace transformation, right? Okay, if you have any doubt, you can ask. Otherwise, you can leave the class now. Anyone has any doubt?
Sir.
Okay, so you can leave the class now.